This is lesson 14.1 about trigonometric identities. In this lesson, you will explain what an identity is, then you will verify identities and determine the domain of validity, and then we'll do these other things in a second video. So first of all, what is an identity? An identity is an equation that is true for all values of the variable for which all expressions in the equation are defined. So in this first example, this is not an identity because the domain for x squared would be all real numbers. And the domain for 5x minus 6 would also be all real numbers, which means the left side and the right side of the equation are both defined for all real numbers. But the two sides of the equation are not equal for every x value. For example, if x is 1, the left side would be 1, and the right side would be 5 times 1 is 5, minus 1 is negative 1. So it's not true when x equals 1. Therefore, this is not an identity. In the second example, the left side of the equation is defined for all real numbers. Domain to this would be all real numbers, except x cannot equal 0 because then we'd be dividing by 0. And the right side of the equation is defined for all real numbers. So this one is an identity because for any x value that we can choose in the domain of both numbers, we would find the left side equals the right side. So if I put a 1 in for x, 1 to the 5th is 1, 1 to the 3rd is 1, and 1 squared is 1. 1 over 1 equals 1. If I choose x to be 2, 2 to the 5th is 32, 2 to the 3rd is 8, and 2 squared is 4. 32 divided by 8 is 4. No matter what value I choose for x, the two sides will be equal as long as I don't choose x equal to 0. That is what an identity is. The two sides are always equal. So these are the basic trigonometric identities. The cosecant of theta is always equal to 1 over the sine theta for every value that is defined for both sides of that equation. You should hit pause right here so you can write all of these down. And then these are some more basic trigonometric identities. The top one is specifically called the tangent identity, and the bottom one is the cotangent identity. Again, you should hit pause so you can write all of these down. Next, we need to define the domain of validity. The domain of validity of an identity is the set of values of the variable for which all expressions in the equation are defined. So let's get an example. In our first basic identity, we have cosine theta equals 1 over secant theta. So the domain to the cosine function, which is graphed here, is all real numbers. As you recall, domain is all possible x values, and as you go across this function, there are no breaks in the curve. It's defined everywhere. The secant function over on the right, though, has breaks in it. There are asymptotes through here, and an asymptote is a place where your function is not defined. So every place where we have an asymptote is an undefined section. So the domain to the secant function is all real numbers except every place where there's an asymptote. And as you recall, as you recall from the last chapter, the secant function will have asymptotes at every odd multiple. So we would say x cannot equal the odd multiples of pi halves. So this would be pi halves here, 3 pi halves, 5 pi halves, negative pi halves, negative 3 pi halves. So this function is defined for everything except odd multiples of pi halves. Similarly, the identity sine theta equals 1 over cosecant theta has some blank spots in its domain of validity. The domain to the sine function is all real all real numbers, so there's no problem there. But the cosecant function, again, has these asymptotes. As you look, you'll notice the asymptotes for the cosecant are in a different location than they were for the secant. So the domain of validity here is going to be all real numbers where x or theta cannot equal pi or any of its multiples. So this would be all multiples of pi. Okay, so that's the domain of validity. In the next video, we will verify some identities.